Let's look at a range of acids. At one extreme, we have alkanes, where there are just carbons and hydrogens bonded with single bonds, all the way through to hydrochloric acid at the other end. What would be a good pKa value for these examples? Well, an alkane is normally a pKa of around 50, and hydrochloric acid has a pKa of -7. So the alkane is a weak acid, and hydrochloric acid is a strong acid. We know to calculate pKa, we must be using water as the base. But the pKa value gives us a sense of what might happen with other bases. For example, if I were looking at the alkane and saying, well, I really want to remove that proton, do I need to use a strong base, or will a weak base do? I look at the pKa value and say, wow, 50. That's a really weak acid, so to have any chance of removing some of those protons, I've got to use a really, 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 really strong base. The minute we add a heteroatom into our organic molecule, that's to say adding any other atom other than carbon and hydrogen to a carbon-based molecule, we see a dramatic effect upon the acidity. We go from an alkane to the next one down, which is an alcohol, and we go from a pKa of 50 to a pKa of around 16. As you can see, water has a similar pKa. Now, if we look at alcohol and say to ourselves, what sort of base do we need to remove the proton from that alcohol? We would say, well, it's kind of a weak acid, so we do need to use quite a strong base. Continuing down, let's take an example of carboxylic acid. It's still an organic acid, but for this case, we have a pKa of 4.8. And for an organic acid, that's quite a strong acid. So again, let's talk about it. We've got to remove a proton from a carboxylic acid. What sort of base should we use? Should it be strong or weak? Well, carboxylic acid is a strong acid, so I think we could remove most of those protons only with a weak base, and that would do it. Now we move from the organic range of acids into the inorganic acids. And as you can see towards the bottom, inorganic acids are typically stronger acids than organic acids. When we're talking about pKa, as we've said, the base is water. So the acid is reacting with water to produce the conjugate base and hydronium. But this is in equilibrium. So if we were to look at a weak acid, the corresponding conjugate base would be a strong base, because that would easily take a proton and that would drive the reaction towards the left, back towards being the weaker acid form. The opposite's true when we're dealing with strong acid. The corresponding conjugate base is now a weak conjugate base, and so it doesn't really want to take a proton, and so the reaction stays mostly in the conjugate base form on the right-hand side.